Good morning to everyone. In the last class, we learnt about the other Fajan's rule, that is size of anion. In that, if anion is larger, it can easily withdraw the electron towards cation. In that, if larger the size of anion, greater its polarizability. Here, the size of the anion should be larger. That ion should have the greater polarizability. In case of cation, lesser the size, it has a high polarizing power. Okay. In comparing these two ions, fluorine has the less polarizability and iodine has the greater polarizability, because iodine has a maximum size and fluorine has a less size. Okay. Last is electronic configuration of cation. Here they are considering two cations having same size and the same charge. Nearly it has copper and a sodium, it has nearly the same size. We have to write the outermost shell electronic configuration of copper and the sodium. Copper 3s2 3p6 3d10, sodium 2s2 2p6. Here 18 electrons are there, here 8 electrons are there. In that, copper has the more polarizing power compared to sodium, because left to right in the periodic table the atomic size goes on decreases. It has a high nuclear charge. From top to bottom the atomic size increases, it has a less nuclear charge. So copper has the high polarizing power compared to sodium. Okay. And in case of polarizability decreases left to right because atomic size increases. Polarizability increases top to bottom because atomic size increases. Okay. Here also the charge increases, polarizing power also increases left to right because atomic size decreases. Here charge decreases, or it may be same, the polarizing power decreases top to bottom at atomic size decreases. Okay. Next we move on to the bond parameters. In that there are 6 bond parameters are there: bond length, covalent radius, van der Waals radius, bond angle, bond enthalpy and the bond order. In that, in the yesterday class we learnt only the bond length. Bond length means the distance between the nuclei of two bonded atoms in a molecule. This is the two atoms, A2 molecule, the distance between the two nuclei. This is the one nuclei of A atom and this is the one nuclei of A atom. This distance is called it as a bond length. Okay. Next, the second one is covalent radius. We have to know about the what is covalent radius. It is 1/2 of the distance between the nuclei and two covalently bonded atoms of the same element in the molecule, This is the definition of covalent radius. Okay. Covalent radius means 1/2 of the distance between the nuclei. Nucleus means a singular, nuclei means plural. It has a 2 atoms. In that is 1/2 of the distance between the nuclei and two covalently bonded atoms of the same element in the molecule. Here there is a condition is there should be a same element. Okay. In the bond length we have to take a different elements also, but in the definition for covalent radius it has to take the same element. For example, here we are taking a chlorine molecule. It means Cl, and that molecule should be bonded with a covalent bond. And another condition is also there, that molecule, the same element in the molecule, that element should be bonded with a covalent bond. Okay, here there are two elements are there. One is chlorine and another one is also a chlorine. Okay, the center is called it as a nucleus. Okay, this will call it as a bond length. This length is called it as, this distance is called it as a bond length. The half of the distance is called it as a covalent radius. This half of the distance is called it as a covalent radius. Here the two elements are same elements bonded with a covalent bond, that is one half of the distance, that is one half of the distance between the nuclei. Between the two nuclei, the half of the distance is called it as a covalent radius. Between the two nuclei, the half of the distance is covalent radius. CR means covalent radius. This half of the distance is called it as a covalent radius. This is all about the covalent radius. Okay, one half of the distance between the nuclei and two covalently bonded atoms of the same element in the molecule. Okay, in that this distance is called it as bond length. This bond length should be always a covalent bond to calculate the covalent radius, and this half of the distance is called it as a covalent radius. Okay, third one is van der Waals radius, that is it is defined as one half of the distance between the nuclei of two adjacent and identical atoms to two neighboring molecules of an element is called van der Waals radius. In that you have to observe here, it is defined as one half of the distance between the nuclei. Distance between the nuclei means it has a two molecules of two adjacent identical atoms. In that there is a two adjacent identical atom, that is call it as a AA. The atom should be identical to two neighboring molecules of an element. It means this atom should have another element. It means it has a molecule. Okay, got it? It means it is defined as one half of the distance between the nuclei of two adjacent identical atoms. Here they have a two adjacent identical atoms. Adjacent means neighboring. Okay, two neighboring molecules of an element. It means this have a neighboring molecule. It means this adjacent atom AA, they are neighboring molecules. Molecules means I already told that in the last class, that is one or more element combined to give a molecule. Okay, it means one or more element, it has a same or a different. Here they are telling a two adjacent identical atoms have to be there. That atom should be have a neighboring molecules. Okay, this is the one neighboring molecule and this is the two neighboring molecule. In that there should be have a identical atoms. Here we are taking a chlorine molecule. Okay, in that this is the one of the chlorine molecule. In that this is one chlorine atom and this is one chlorine atom, and here also this is the another chlorine molecule and this is one chlorine atom, and this is one chlorine atom. These have the nucleus of, this is the nucleus of this chlorine atom, and this is the nucleus of this chlorine atom. This, in this distance, the half of the distance is called it as a van der Waals radius. Did you get it? The distance between these two nuclei, in that the half of the distance, that should be called it as a van der Waals radius. Got it? In the covalent radius, they have only a identical atoms. It means one molecule is there. In the van der Waals radius, there are two molecules. In that, the identical atoms. In that identical atoms, the bond distance, the half of the bond distance is called it as a van der Waals radius. Here also there are nucleus. This half of the distance is van der Waals radius. All of you get it? It is defined as one half of the distance between the nuclei of two adjacent identical atoms to two neighboring molecules of an element. In that, here they have a molecule, and in that molecule the bond should be in the bond formation should be in the identical atoms, and in that the bond length, the half of the distance, is called it as a van der Waals radius. Okay, this is all about the van der Waals radius. Next is fourth one. Fourth one is bond angle. Bond angle, you have to know about that. What is bond angle? It is defined as the angle between the orbitals, containing bonding electron pair around the central atom in a molecule. It is called bond angle, or other definition is also there. The simple definition is bond angle is the geometrical angle. Bond angle is the geometrical angle between two adjacent bond. Is called bond angle. Okay, in that it is defined as the angle between the orbitals containing bonding electron pair. It means there will be one central metal atom, you have to consider as a M, that should be bonded with the X. Okay, these are the orbitals containing bonding electron pair. Bonding electron pair means it has a capacity to bond with the other element. Okay, it contains a bonding electron pair to bond with the central atom in a molecule. This is called as the bond angle. Okay, in simple way we have to know about that. Bond angle is the geometrical angle between the two adjacent bonds. Two adjacent bond means here they have a M, X, X. This have the two adjacent bonds. Okay, in that this angle is called it as a bond angle. Okay, in that for water molecule, here O is there, H, H. This angle is called it as a bond angle. The angle of water is 104.5 degree. Okay, and also for BF3 molecule, here B, F, F, F. Okay, this is also called it as a bond angle. It means adjacent. Adjacent means akkapakka, neighboring, 120 degree, and this also 120 degree. This is all about the bond angle. Bond angle means it is defined as the angle between the orbitals containing bonding electron pair. It means this orbitals should containing a bonding electron pair that should be bonded with a central metal atom. That angle is called as a bond angle, or in simple way we can also say that it is the geometrical angle between the two adjacent bonds. This is the bond angle. Okay, this is all about the bond angle. Next, fifth one is bond enthalpy. Fifth one is bond enthalpy. Bond enthalpy means it is defined as the amount required to break 1 mole of bonds of a particular type between two atoms in a gaseous state. Okay, this is called it as a bond enthalpy. And this bond enthalpy means some energy we have to require, heat energy. Okay, and bond enthalpy means we have to break it. It is defined as the amount required to break. Bond enthalpy means it is the amount required to break 1 mole of bonds of a particular type between two atoms in the gaseous state. It means the bond will be break at a gaseous state only, not in the liquid state and not in the solid state. That should be only in the gaseous state. Okay, here chlorine as in the gaseous state, it is Cl. Okay, this will be breaked. It gives chlorine radical. It means plus chlorine radical. Here you have to see this. For formation of one bond we need 2 electrons. Okay, when it breaks down, one electron should be get one atom and other electron should be get the another atom. Okay, so that's why this single electron is called it as a free radical. Okay, for breaking of this bond, that energy is called it as a bond enthalpy. Did you get it? It means that some amount of energy required to break a 1 mole of bond. It means 1 mole, only 1 mole. Here we are giving only 1 mole, here also 1 mole. Okay, of particular type. It means it is a sigma bond or a covalent bond or a ionic bond between the two atoms in the gaseous state. These two atoms should be in the gaseous state. The unit of bond enthalpy is kilojoule per mole. Kilojoule per mole. For example, for oxygen molecule also, it gives O gas plus O gaseous. Okay, the bond enthalpy is 498 kilojoule per mole. Did you get it? The here O2 molecule, here also 1 mole. Okay, 1 mole. That should be break the bond between oxygen atoms. How much energy is required? 498 kilojoule per mole is required to break the bond enthalpy. That should be called it as a bond enthalpy. Okay, it means some amount of energy required to break 1 mole. That compound or molecule should be in the gaseous state, should not be in the solid state or a liquid state. Okay, next last parameter is sixth one, bond order. Bond order. Okay, bond order means bond order given by the number of bonds present, number of bonds present between the two atoms in a molecule. Okay, bond order means that should be given the number of bonds present between the two atoms in a molecule. That should be, we have to calculate in between two atoms only. Okay, here we are giving XX. Okay, X2 molecule. It forms only a single bond. How many bonds are there? Only one bond. One bond is there. Only one bond is there. Okay, this should be given by the bond order. For example, for hydrogen molecule, it gives H. It forms only a single bond. It means bond order is 1. In your previous classes, it means first PUC and second PUC classes, you have to learn about the bond order. And also, for example, oxygen, O double bond O. Okay, here also it gives a the bond between it, only the bond between the two atoms only we have to calculate the bond order. The bond order of oxygen is 2. Here how many bonds are there? There are only 2 bonds. Or for example, in hydrogen fluoride, it gives HF. How many bonds are present? Only 1 bond. The bond order is how much? The bond order is 1. Okay, the how many bonds are present in that molecule between the two atoms, not all the atoms present in the molecule, between the only two atoms, that contains how much bonds, that should be directly proportional to how many bond orders are there. Here H2, it has only single bond, so bond order is 1. Here O2, here there is a 2, so bond order is 2. For nitrogen, N2, N triple bond N, so bond order is 3. Here there are 3 bonds are present, then bond order is 3. These are all about the bond parameters. It means bond angle, bond enthalpy, bond order, and van der Waals radius and covalent radius. Thank you one and all.